Okay, we're going to get started today. Looks like we have quite a few people online and not so many in class. Oh, just one. It's early so far. We'll see if we get any more. Hey, I see Alex and Mason and Ariana are all online. So, and Joe just stopped by and said he wasn't feeling well, and so he wasn't going to come to class, which I appreciate because I don't want to get sick either. So, uh, all right. So let's see. We are starting. Hey, Johnny decided to come to this class. All right, so we're starting unit 12. So this is in our series of units on like using large language models in different ways here. And we're going to talk about retrieval augmented generation. This is supplementing a large language model with data and telling it to use that data to answer a bunch of the questions for it. And this has been a big thing for the last year and a half. Ever since, it was quickly realized that large language models had some issues. They like to make up data and stuff like that. And they didn't have access to a lot of data that was out there. And so they had some limitations that were recognized pretty early on. So people were trying to look at how to improve them or and address these issues. There are also issues where companies wanted to use large language models, but the companies have a lot of proprietary information that is not on the internet, but they wanted to use AI to access. And this sort of system allows large language models to use this kind of proprietary or private information, be more accurate, not lie or make up facts as much, and things like that. So we're going to look at these sorts of systems this week. We're going to actually, so a couple of things. The course is shifting a little bit. One thing is that usually this is an even week, so we would have the project due at the end of this week. But remember, last project we spread it over 3 units. And so this time the project is going to be unit 12 and 13. So it won't be due until next week. You can actually do it. You'll be ready to do the project at any time here now, and it's posted there, but you won't be due till next week there. And again, next week's a little different because we won't be doing any like code or stuff like that. We'll be doing some research into humanoid robots and how robots kind of work, and having students do reports on different robots next week. So that'll be our setup there. Okay, so the project isn't due till next week. The learning activity we're going to have to is actually broken up into 2 parts. We'll have a notebook we'll do on Thursday there, and I haven't quite updated that. Again, often these notebooks, there's a lot of library and stuff changes since last year when we did this, and so I have to update it. I think I have this basically working, but it's not entirely working yet. So don't do that. Thursday, I'll fix that up tomorrow. But today we're going to do part 1, where we're going to look at a RAG system that vendors have that you can use without writing any code or using any code here. So let's jump into this sort of system. So I'm going to start with the learning resources, and then at some point we'll use that to do some of the learning activity part 1 today. Okay, so again, we talked about prompt engineering, defining clear prompts. We've been spending a couple weeks talking about AI agents and writing those, both in code using LangGraph and with Crew AI, and then some of the other non-coding options. And we're going to look at this retrieval augmented generation here, RAG systems, adding data retrieval to LLMs this week here. And so we'll look at what the basic idea is. We'll look at today we'll look at some non-programming options, how you can use these systems without doing any programming, just with vendors. And that'll be part one of the learning activity. On Thursday, we'll look at programming our own RAG system and how that works. So what is retrieval augmented generation here? Well, for this sort of stuff, I still like IBM as a really good source here. Now, they have a nice article on this that talks about retrieval augmented generation. So again, it's a AI framework for retrieving facts from external knowledge base to ground large language models. Okay, again, so to ground or provide them data to provide more accurate, up-to-date information and give you, users insight into the generative process. So again, they talk about some of the problems. LLMs can be inconsistent and out of date here. This is a long article. They talk about it, and it's it's not that long, but it's a lot of text here. I actually want this article just for the video, and I actually linked this video in right here. So this is the best part, and we're just going to watch this video because I think IBM videos are actually quite good these days. So we're going to watch this video.
And I want to tell you about how large language models be more accurate and more up-to-date. Retrieval augmented generation, or RAG. Let's talk about the generation model. So forget the retrieval augmented. So generation, this refers to large language models, or LLMs, that generate text in response to a user query or a prompt. These models can have some undesirable behavior. I'll tell you an anecdote to illustrate this. So, right here, they recently asked me a question. In our solar system, what planet has the most moons? And my response was, oh, that's really great that you're asking the question. I love space when I was raised. Of course, that was like 2 years ago. But I know I read an article, and the article said that it was Jupiter and EU. So that's it. Now, actually, there's a couple of these columns in my answer. First of all, I don't to support what I'm saying. So even though I confidently said, "Read an article, I knew the answer," I'm not going to say it. I knew the answer off the top of my head. And also, I actually haven't kept up with this for a while, and my answer is out of me.
My kids think this is hilarious because when they were young, they didn't quite understand this, but now they're old, they're older than you. And so they think it's really hilarious that I just make up answers. Well, I just say things as a dad that I pretend they're true. And I often don't know, or I think they're true, but they realize now that many things I say just are not true because I'm out of date on a lot of things. And so same thing here. I just like that. So
Two problems. One is hillbilly, and the second problem is that I am unaged.
Okay.
And these, in fact, are two behaviors that are often observed as problematic when interacting with large language LLM challenges. Now, what would happen if I had taken these and first gone and looked up the answer on a reputable source quick now? Then I would have been able to say, okay, so the answer is scattered with 146 moves. And in fact, this keeps changing because I just keep on right doing the moves. I have now grounded my answer to something more believable. I have not hallucinated or made up the answer or related to personal information about the things and how this has to state. All right, what does this have to do with large language models? Well, how would a large language model answer this question? So let's say that I have a user asking this question about food. A large language model would confidently say, okay, I have a great and what I know in my parameters during my training, the answer is 0. The answer is wrong, but
okay, while you're watching this, it'd be kind of fun if you went into some of the large language models and asked them that. Now, traditional large language models cannot search the internet there. And so like if I go to Chat GPT and go to 4, it doesn't do search. So I can ask what planet has the most moons? How many does it have? And again, somewhat old. Saturn holds record and it says 83. So again, you should try this now. Some of these ones will let you search, add internet search, which is the beginning of RAG, and some will add deep search. So see, again, this is talking about LLMs that don't have this searchability in them.
Now, what happens if you have a single offense part here? What does that mean? I mean that now, instead of just a line for what LLM is, we are adding a context. It could be open by the internet, it could be closed, like some collection of documents, collection of policy, whatever. The point though now is that the LLM first goes and talks. The context store says, hey, you retrieve for me information that is relevant to what the user queries. And now, with this retriever augmented answer, you know that it's static. What does this look like? Well, first, user prompts the LLM with the question. This is my question. And originally, it was just probably the generative model. The generative model said, oh, okay, I know this one. Here it is, the generative model. But now, in the land framework, the generative model actually has an instruction that says, no, first, load and retrieve relevant content. Combine that with the user's question, and then generate the answer. So, the prompt now has 3 parts. The instruction to pay attention to the retrieved content together with the user's question, now to the response, and in fact, now you can get evidence for why your response was what it was. So now what you can see, how does that help the 2 LLM challenges that I mentioned before? So first of all, I'll come to the outdated part. Now, instead of having to retrain your model, giving information on it, like, hey, this sounds like more blue. Now, Jupiter again, maybe Saturn again in the future. All you have to do is augment your data set with information, updated information. Now, next time that user comes and asks the question, great, we can go ahead and retrieve those updated information. The second problem, sure. Well, the learning model is now being instructed to pay attention to primary source data before giving its response, and in fact now being able to get evidence. This makes it less likely to hallucinate or leak data because it's less likely to rely only on information that acquires during training. It also allows us to get the model to have a behavior that can be very positive, which is no one's going to say I don't know. If the user's question cannot be widely answered based on the data store, the model should kind of know that making out something that is believable actually means to the user. This can have a negative effect as well, though, because if the retriever is not sufficiently good to give the large language model the maximum high quality ground information, then the user query that uses that model doesn't get an answer. So this is actually why lots of folks, including many of us here at IBM, are working to follow the both sides. We are both working to improve the retriever to give the large language model the best quality data on which the relevant talk, and also the generative part so that the LLM can make decisions and respond finally to the user when it needs.
Okay, so that's a basic introduction to RAG models. Again, and so we're going to provide data to our language model. Then we have to retrieve, we have a big data store and we have to retrieve the right data to give it there. So we're going to look at a couple other vendors and hear what they talk about, so NVIDIA talks about RAG systems here. And again, this whole idea of RAGs are since we started using LLMs here. So we started with 220 in 2020 with the first papers on this sort of idea. And again, combining internal and external sources for this. So and setting this up for this. So again, they talk about some ideas here and how you would set up a pipeline here. So again, the idea is that you have some data or some documents or whatever. You're going to extract some data and do some filtering. We have to do some manipulating to get it in the right format, and then we send it down to our database or system here. And then when the user asks a question here, we're going to go to our knowledge base, grab our data out of that database, and feed that to our LLM and get a response back to our LLM. This is a different, I think, a little cleaner or a different version of it. So we ask a new question of our LLM, and our LLM usually has our chat history that feeds into it also as part of this. And so that gives us a kind of a standalone question that we have from our LLM, or they're sent to the LLM. But we are going to kind of intercept that, and we're going to take that question and use that to look at possible answers in our documents. So relevant paragraphs or pages in our documents that are in, and we're going to pull out relevant pages or parts of our documents here that seem to be related to our question. So we might have 10,000 pages in our database here, or even just a couple hundred, but we can't send that all to our LLM. We can send 3 or 4 pages, maybe even 10 pages to our LLM. So what we want to do is go out to our data store, in this case, a vector store, and say, give me the pages that seem like they apply to this, and it'll grab those pages. And then we're going to feed our question to our LLM with this document saying, and we're going to modify our question. We've seen how we can do this. We can take a prompt and modify it, put it inside a template, and now we'll have a template. It'll say, so looking at the following document pages or whatever, answer the following question, and then we'll provide the question and we'll find the pages there. And then we'll feed that bigger prompt to the LLM, and the LLM should be able to come back with a much better answer. An answer that'll say, well, according to this document, this page of this document, and this page of this document, the answer is this. Or it might actually say, oh, I looked through these documents, it doesn't seem to say, I don't know the answer from the documents you gave. And so it'll sometimes say it doesn't know, where in general, LLMs never say, I don't know, unless you ask it a specific question like, can you answer this from this document, these documents? So another company that I think is pretty good on this is Oracle and their system. So again, they're talking about what RAG, retrieval augmented generation. Again, we're doing data retrieval and adding that to our LLM generation, our language models here. And we're trying to set this up and get this to work. So again, what are our, one more. What are our key benefits that we've seen? So RAG has access to information that may be fresher than the data used to train the LLMs. So again, we might be providing new data. Like today, we'll look at using RAG to say, what courses should a computer major take this fall at St. Scholastica? And so if we ask a general LLM, the general LLM doesn't even know what courses are offered, but we can provide a list of courses that are offered to our LLM. We can have that in our data store. We can have the newest class schedule, the newest catalog copy and stuff like that for this. So that's helpful. Data in the RAG repository can continually be updated without a lot of, it takes a lot to train a new LLM. And we'll look at that, next, in 2 weeks, we'll look at fine tuning on LLM with new data. But again, that's going to take lots of, millions of dollars usually to add stuff to an LLM here. But here we can just add data to the data store and feed that to the LLM. So, again, the knowledge in the repository can contain data that is more contextual, more related to your problem than the general data trained on the LLM for that. So particularly, if your company or your organization have particular data, proprietary data, stuff like that, knowledge that is out there, like, the LLM is not, AI hasn't been trained on what courses St. Scholastica is offering here, but we have that data that we can provide this model. So, and again, finally, the sources of information can be identified here. When we pull these pages out, we can pull them out and tag them and say, this is from page whatever of this document. So then when the LLM sees it, it can say, oh, refer to this page of this document correctly. Let's look at AWS. So Amazon talks about these RAG systems somewhat. Okay, so again, here's another view of that system. So again, we are putting step one, we're putting some prompt into our RAG system here. So that's some question as part of our prompt. Now, with that, we are going to take that question and feed it into our retrieval system with our data sources, our documents over here. So we're going to take our relevant, our query, we're going to say, find matching documents or pages from the documents that could relate to this question. So again, if we're looking, if I say, what courses should a computer major take in fall 2025, it should be looking up and maybe finding the schedule for fall 2025 as opposed to the spring schedule. It might be looking, it might even just pull the computing classes out of here. Now, this process of grabbing the right data sources is important because, again, if it just grabs the computer courses, only recommends those, you might need some non-computer courses there, and it might not be pulling those in. So again, this idea of getting the right matching information and pages and pulling that in here is important. So we grab the relevant information here and the context, the source material, or the metadata about it. Where is it from? So it can reference that. We bring that all back to our system. And now we generate a new, more complicated prompt with our query and our data sources, our pages that we retrieved. And we send that all to our LLM, like OpenAI or Gemini or whatever, with that and say, looking at these documents, can you answer this question? And here's the question. And it can reply back with the answer and source those documents for us. So that's kind of what we're setting up here, just another view of that sort of stuff. And they have a bunch of notebooks here about using, again, different large language models and different data sets. You see they're using something called Pinecone. And so we'll look at Pinecone again on Thursday when we create our own stuff. Pinecone will be our database system. I know if you're a computer person, you probably learned SQL and how to store data in SQL systems. We are not going to use SQL data for this. SQL doesn't work very well for this kind of data because the data tends to be unformatted data. It'll be like just a document. And so in a document with multiple pages, we don't have a nice, easy way to go in and find the relevant information with SQL there. So we have to use a separate kind of data store here. We'll talk about that on Thursday. So, okay. So now we're going to look at a couple vendor solutions. And we want you to do this. I'm going to make you do this with one of these vendor solutions. So we're talking about, you might be starting to look and do this. So for your learning activity 12, you might want to open up the learning activity write up. And again, for part 1, you're going to use a vendor's RAG system. So we're going to select a vendor, select some documents, try out, implement this and try this out and tell your results. So you should be able to do that all today in class here. So let me go back here. Hoping this works. One of these things work, because I often get in trouble because I seem to have access to systems that you don't have access to. And it's sometimes hard for me to tell what I have access to and why versus what you have access to and why. So we'll try this out. I think you can use Google's Notebook LM. So let's try this out first. So our first one, and I think this is the coolest one, is Notebook LM from Google. So when I click that, I get here notebooklm.google.com. And even at St. Scholastica with my CSS ID, I can access this, where I can't seem to access Gemini here, which is interesting because, again, if I go to Google and I just go to Gemini at Google, that seems to get blocked here. So I don't know why that is, but I've talked to IT for hours on that. But Notebook LM seems to work here. So, and again, you can create a new notebook, and you're going to want to do this. I'm going to show you some other notebooks I have out there. So again, I often create a notebook for my classes out there. So here's my notebook for software design here. And it has some sources. So it has some articles. It has some actually full textbooks here that we reference from Microsoft. It has the syllabus from the course, and it actually has the first couple introduction notes from the course there. So there are some all these sources are added into this. And then I can ask some questions of the course here. So, let's see, what are we covering in week 2 of this course? And again, it should be able to tell you that, so it feeds it to you. It tells me what dates, what we're covering. It should include sources of information that it has, so it should be listing. So it's grabbing the Unit 2 notes here and listing this out and what we're covering in that course there. So again, it should be able to answer this stuff. Let's see if I don't have the Unit 4. Let's see if I can. What are we covering in Unit 8? See if I can answer that or not. Yeah. Oh, it has the syllabus. So it has the full syllabus, so it knows what I'm covering every unit. So I thought since it didn't have the Unit 8 notes, it might not know what we're covering, but it has the Unit 8. It has the syllabus and it has the textbook, so we can figure that out pretty well of this. So a lot of people talk, there's a little podcast thing that you can do with this. You can do a overview of this. So if you ask it some things, you can have it do like a little podcast about whatever you're talking about here. So that's the idea. So I want you to create your own notebook here for this and drop in some documents. So again, you can decide what you want to do here and what documents you want to do for this. So it can be like for one of your courses, you have the syllabus, you have notes, you have like PowerPoints, you have PDFs from the professor. Do you have the textbook as a PDF? Can you drop that in there? What can you drop in there? Maybe you're interested in sports. March Madness just finished, national track, soccer's going on. So maybe you want to drop in stuff. Maybe you're, fantasy football, fantasy soccer league is going, or you want to drop in some key stats here. So maybe what are some documents you can drag in and drop in? Maybe you're very interested in some Star Wars or Star Trek, maybe we want a Harry Potter expert in here, and maybe you have PDFs or versions of the Harry Potter books. You want to drop those in and ask it questions about those texts and things like that. So again, you can decide whatever you want. Maybe you're interested in travel or gardening. It's almost spring here. I'm getting very excited about gardening here. So maybe I want to drop in some gardening information in there. Now, you can drop in documents from Google Drive here. You can link in websites. So maybe there are just a couple websites that you find very trustworthy that you want to link in, or you can paste in some text in here, or you can just drop in documents. So I think I'm going to do, again, try to have it look at what classes I should take or something like that. So if I look at, I think I'm going to have to go back to the learning activity because I don't have it linked in here. In the learning activity, I have the CSS source documents here. So I have like the fall schedule as an Excel spreadsheet. I have the Scholastica catalog. Some of this isn't all up to date, but some of it is. I have the student handbook. Here I have some different handbooks here that I can drop in. I don't know why. I must have downloaded this one for some reason. Let me do this. Okay, so I can do a couple things. I can download these things. I'm going to download this this spreadsheet, store it somewhere. And then I'm going to go back to my notebook and I'm going to drag and drop it in here and see how it does. So it will work better with some documents than others. So again, I'm trying to drag this spreadsheet here. It won't handle the spreadsheet, right? It's saying it wants it in PDF, text. It looks like any of the audio formats, even some video formats, but it's not handling a spreadsheet. So that's not working. So sometimes you have to do some manipulation. I'm going to open this document and save it as a text file, I guess. So I'm going to go to this page that actually has all of the schedules, and I'm going to save as and switch it to a text file. Okay. So again, it's not going to work with everything. So now I've got a text file. I can drag and drop it in here. I can add other sources, and some of them I can just grab from Google Docs. Rather than having to search, I should be able to just go and hopefully do like my catalog. Not helping. I'm going to this folder and finding it and inserting that. So again, between downloading these things and adding them or just adding with Google Docs, you should be able to add these things in here. So let's see. There. And again, once you get those, again, you can also add some websites. So maybe I'll just want to add css.edu to say, can you just add that? Oops. Okay, I'm going to go to grab that URL in the right format. There. And add that. Oops, and then I'm going to ask some questions. So what computing classes are offered in fall 2025? See if it can read through that and figure that out with the documents given there. And again, what you'll do is you'll see sometimes it's going to be okay in finding these answers, and sometimes it's not it's not going to find them. Again, because again, it's like I have the class schedule as a big text file. I'm not sure how good it's going to parse that text file. I'm saying computer classes. I'm not sure if it can know that CIS is computer class or whatever, but here's it listing the courses. It's finding the courses that are offered, and then it's pulling from the catalog a description of each of those courses, it looks like, for that. So it seems like it did a pretty good job at that for this. So that's your plan, is to create one of these information. And again, you can also do a deep dive with two hosts. Let's see, let's generate that. Going to take a few minutes because I think just doing a summary of all the documents I have here and going to tell me about that. So in a little bit, so we'll let that run. And again, your job is to figure out set this up in one of these RAG systems. We're looking at Notebook LM, and then in a little bit we'll do OpenAI's custom GPTs here. I'm not sure if you have access to those or not. So we'll walk through that here. And again, the idea here is that you can compare this to just a general LLM. So if I ask ChatGPT, what computer courses should I take at the College of St. Scholastica for fall 2025? It'll be interesting to see what it can come up with. It can probably find the catalog there, so it's finding the catalog, but it's not finding the actual course schedule. So it's recommending courses here that aren't offered in the fall, but are in the catalog. Again, it's coming from the course catalog here. So again, this is just a general system because it doesn't have access to our course schedule here. Even if we switch this to a newer, let's try to do a thinking. Oh, let's do 4.5, this brand new model. See, it should think about this. It should search the web. Yeah, it'll do a lot of thought trying to figure out and come up with things. And again, it just pulled things from the course catalog. It pulled different courses here. But again, it's recommending courses that aren't offered in the fall. And it doesn't know when these are offered in the fall either for this. So again, this is without the RAG system, where with the RAG system, it should know, it'll pull out and it can actually go to our source and say, this course, here's the course information, who's teaching it, and stuff like that. So, and I can ask it, okay, so what are good courses for a second year computer student? List the courses, the course number, name, and who is teaching it in fall 2025. So again, it's looking at courses and who's teaching it. It's trying to specify that. And again, it says there are some courses that are typically taught in the second year, but they're not found in the fall 2025 schedule. So it knows that here. And same with Java 2, it's recommending Java 1. Pretty good. Knows I'm teaching it there. And database modeling here. It's just, yeah, and mobile device programming. I don't know if that's a great one for second year students, but again, lists some of this information. And again, you can see how it has access to this specific information here. So again, you can load this in with whatever information you want here. Oh, okay. So our audio overview is ready. We're going to click on that and see how that sounds. Let's see.
Welcome to another deep dive. Today we're going to take a look at the student handbook and the catalog for 2023 to 2024 for the College of Scholastic. Right. And this is kind of you've been looking at this, kind of getting a feel for what it's like to be there, the rules are, the classes, and all that stuff. Right. So we're going to go through this stuff and pull out the important details and see if we can't make some sense out of how it works. Sure. And maybe point out some interesting things along the way. Right. Kind of give you like a real feel for what it would be like to go there, right, without you having to actually read through all this kind of thing. So to kick things off, why don't we take a look at how Scholastica deals with student conduct issues?
Yeah, so one of the things that I think is really interesting about Scholastica is that they have something called formal hearing options. When a student has potentially violated.
So that's their podcast summary of this sort of stuff. What kind of scares me is if I load in one of these with a weekly unit and the chapter for that unit and then my lecture notes from that unit, I think it creates sometimes a better podcast than I can explain it there. So yes, I'm not saying that I'm going to be replaced by AI, but I might be replaced by AI. Okay. So this is Notebook LM. Has anyone used Notebook LM yet? I know it's been in my feed now for over a year, a lot talking about it. Has anyone used this? No, you chat people, if you have, put a chat in the chat. I'll keep that open so I can see that. Oops. Put it over here. Okay. So And like I say, I really think if I were a student, I would start creating one of these for each one of my classes and load this in with stuff for my class information there. Now the question is like textbook, what? But I find students are surprisingly good at finding PDF copies of their textbooks, even if they're not 100% copyright legal there. So, not saying you should do that, but I'm just saying I know students who do that and load it in here. So, okay, let's go to our next one of these. Okay, so besides that, so that's Google's version of it. We can look at OpenAI's version of this, custom GPTs here. And again, I'm not sure if you can do custom GPTs. I thought you could nowadays, but again, I know I can with my subscription. So, so what is this sort of stuff? You can create a custom GPT. So like here's one about Duluth there where I provided some information about Duluth and stuff like that here. And here, if I go to create, oops, oh, here, configure. So again, here's my Duluth guide. I can hit configure. I give it a name, description, instructions. So this is the kind of instructions to it. And then I give it some possible conversation starters. So again, you can see this. It's putting the guide here. It's putting the description here. And here's the conversation starters that are listed here. At one point, ChatGPT thought that, I mean, there was a big push to have people create these for different things. And whoever, they were trying to monetize that. And if you were getting a lot of people to visit or use your GPT, your custom GPT for something, you could earn some money or something like that. Okay, so that now knowledge, we can upload files to this. So I can go here and upload files about Duluth here. I can let it search the web or do other things. I can have it run code. I can use Canvas or use image generation here, and I can create some new actions for this. So again, if we want to do the same thing, if I want to create, and again, it looks like I just have, so maybe I have some, I'm just going to edit these untitled. I think every time I go here, it creates an one of these untitled ones. I'm going to delete actually some of these. Okay. And let's just edit one of these. So I'm going to just edit one of these untitled ones and edit. Okay, so we want to configure this. This is going to be a Scholastic advisor recommends courses to take for next semester. And my conversation starter is like, what courses should a computer major take? Let's say a second year. Or what are Veritas history classes? Okay, and then for knowledge, we're going to try to upload some files and we're going to see what it happens. So can it process a spreadsheet? Remember, the last one couldn't handle a spreadsheet. So it's bringing in the spreadsheet just fine. Can I bring in a PDF of the catalog? Bring in that, fine. So again, I can upload my files for this stuff. It looks like it can upload a fair number of files here. So And again, we can have web search availability. I'm not going to let it do image generation or Canvas stuff. But one thing is it's just doing general web search. I can't necessarily limit it to one or two websites like the other one is. And I prefer it when I can limit it to certain websites here. Okay, so that's my idea. Let's see if I can just hit create. Okay, and I'm just going to click on this and see how it does. It's searching its knowledge. See, it says that, and see how it does with that. Okay, and I didn't ask it for a particular time, so it's just looking at the catalog here. So now I'm going to ask what 2000 level computer courses are offered in fall 2025. See if it can answer that. Now, on both of these, for your write-up, we want you, once you get it all set up, so you know, which vendor do you want? Are you using ChatGPT, Notebook LM? And again, there are some other vendors out there. I'll try to link in a couple more. I just wanted to demonstrate these two main ones because I think they have most of the market out there. Then again, what documents or websites are you uploading? You have to have at least 2 or more documents or websites here. And then we want to test out a query that your system should be able to answer and a query that your system that should be outside your system's data here. So again, I asked it what programming courses were in the fall 2025 schedule here. And it looked it up and it said 2085 and 2087. So it got 2085 right. 2087, of course, is a spring course. Programming 2 is all only offered in the spring, not in the fall. So it did not get this correct. That's interesting. So again, what if I ask the same thing of Notebook LM here? Again, it's only finding 2085, which is the only one and stuff. What if I ask it something that I don't think it can know? So like, what if I ask it what courses are offered in the spring 2026? Again, one thing we're trying to test out, and again, we'll see this on Thursday, is that some of these systems will be able to tell us, we'll say, I don't know here. And this one is just looking at the catalog and making something up based on the catalog. And again, not correct. So it's not giving correct information here. So again, here it's not bad. It says the course schedule only consists of courses offered in fall. And it says, so then it says, here's it. Now then it says the catalog has the following and lists the ones that are in the catalog. But it says the catalog is for 2023, 2024. And it doesn't specify courses offered in spring 2026. And again, it said noted previously that 2011 was not offered in the fall, even though it's listed in the catalog. So it's guessing that 2011 is going to be offered in the spring, but it doesn't know. So it actually, I think it does a pretty good job. It's guessing, but it's telling me it's guessing there, and it's guessing correctly for that. So I think Notebook LM is doing a little better job than this version, this custom ChatGPT. So again, once you configure this and set this up, you can, and I'm just doing preview, I can hit create. It can create this GPT only for me or anyone with a link here, or I could put it in the store and make one and make lots of money off of it. I'm sure that's what I'm going to do. So I can save this custom GPT. In the same way with the Notebook LMs, if you create a notebook LM, you can share it. And so again, with one of these classes, I created it for the class, and then I shared that link with people too. So you can actually share it just like you do with Google Drive, and they can go into this notebook LM and access it.
If you create a GPT, but you have a migration and you share it, are other users able to use it or no?
I think so. So I think so. Here's my settings saved. So I think, yeah, I think if my settings cost got so if I open up a incognito window, right, not logged in, and I paste that link in there, I can get what, but it says sign up to chat. I wonder if that'll work. I think you can access it even. You can't create them, but I think you can access any of them. In fact, you can go to the chat GPT store. Have you been to the chat GPT store? List the top chat GPTs. Oh, I don't know if that's the chat. I think this is the one I want. Explore GPTs. Chatgpt.com/GPTs. So these are the best free one or custom ones that people have created out there for different things. Some are from ChatGPT, some of them are for different things here. So again, and you should be able to access these regardless. I think you have to be logged in, but again, you don't have to have a paid subscription to access, I don't think, these ones for this. So like there's one that's just linked into Expedia and uses Expedia, stuff like that. So you can try out some of those sometime. Again, a lot of these are based on this RAG model also. Now, one of the things that this did give us early on was the ability to search the internet. But again, now most of them allow you to search the internet. So again, OpenAI will do this. If I go to DeepSeek. Oops, I should have gone to the English. Oh, it's, yeah. And goes there. Again, I can turn on and off search here. Similar to Gemini, I can turn on and off search. My experience now, even turning search off in Gemini, it still searches the internet when I've been trying it out. So again, some of it access to the website, but again, this is searching all the internet, and you cannot specify it. I'm creating for another project, I'm working with an organization who wants a kind of a Duluth-based chat bot. And I was trying to figure out what documents to do. And so what I did is I was looking at kind of public domain documents. So I looked at Wikipedia, but rather than searching all of Wikipedia, because there's a lot of stuff on Wikipedia, what I did is I looked up Duluth and a couple Duluth things, and then I looked up the top 100 links from the Duluth pages. And so like Wikipedia has web pages as pages on every neighborhood in Duluth and a lot of the organizations in town, that sort of stuff. So I just scraped the Wikipedia pages. I think I scraped 200, 500 Wikipedia pages related to Duluth and put those in a document there. And then I haven't tried, but I'm going to try to use that in one of these RAG systems about Duluth a little bit. So I'm still, and again, the other thing I'm trying to look at is what other public domain or, access documents I can access. Like I've been looking through the city of Duluth. The government sometimes has good documents about the city that I can access. So, okay. How are we doing here? So, I'm going to go back to the lecture here and talk a little bit. Again, your job is to just make sure you have done one of these RAG systems, either Notebook LLM or ChatGPT. And again, do part 1 of the write-up today. Part 2 we'll do on Thursday. Okay, but I'm going to give you a preview of part 2 there. So again, we can create our own custom RAG system there. We're going to use LangChain, which we've used before. That just allows us to send queries, get the results, take those results, and send them off to another LLM, or send them again to an LLM, or combine documents and send them to an LLM. We're going to use that. And then we're going to use Pinecone. That'll be our database system where we can store documents and pull back documents. And we're going to use, again, an LLM for this. And again, we're going to take the documents. We're going to take the student handbook, the college catalog, and the class schedule, just like we did already, feed that into the systems here as our RAG system. So again, the first thing we have to do is prepare our documents here. We're going to take our documents and we have to load them in. Again, we're going to run into some issues because we can't load in all documents here. Like, I don't think we'll be able to load in spreadsheets. I think we have to load in text files or PDF documents. So we'll have to make sure we do that, and we'll load them in with this. LangChain has a document object we load them in with. Now, the documents have to be split into chunks, like I was saying, pages that you talk about, this page or that page. Pages are kind of a human thing, so we're not going to actually use pages so much with a big text document. So we're going to just talk about how many characters. So often you do like 1,000 characters there, which is maybe a page or part of a page there. So we're going to break our text up into 1,000 character chunks. And then again, we want to generally have overlap. So we'll often overlap that by 100. Because again, it's kind of arbitrary where it just starts chopping things up by every 100 characters. And it might, you know, if we're like looking at the course schedule, it might break that course schedule right at a very bad spot here. So if I look at my course schedule here, here's my course schedule here. And again, it starts, where's my computer courses? Oops. Okay, so let's say it's going through here, and again, it is, you know, grabbing 1,000 characters. That might grab and end up like here in the middle, and so it might miss that CIS, you know, 101 is offered or whatever, because it's cutting right in the middle of it there. So instead, we'll overlap it. So this one will go up here, and the next one will start here, back 100 characters, and go on there. With data, it's not great on it. It's better. It makes more sense when you're looking more at like a PDF document where we're just doing text overview. Okay, so we break it up into chunks here. Then we're going to create embeddings for every chunk. And if you remember our LLMs, we kind of create tokens or convert these into numeric. So an embedding is a high dimensional vector related to each chunk. So we're going to look at this vector encoding for each chunk. And again, this is kind of what LLMs do. They do it on a token basis. We're going to do it for a whole chunk of words and try to characterize this 1,000 characters. So 1,000 characters, what is that? So average word length is maybe 5 characters. So that is about 200 words. So for every 200 words, we're going to have a vector of stuff. So again, we're going to create this embedding, this set of numbers that are going to encode every chunk, every like 200 words there. So now that once we have these embeddings and the text, we're going to use this database called Pinecone. And again, there's a bunch of people who have this. Pinecone we're picking it simply because it's free to use, and it's the most popular free option for us to use. So that's one of my criteria, is we want to use something that's well known out there, but that's also free for us, free for students. So that's what we're using Pinecone for. So we're going to create a Pinecone data store, and we're going to store this data into it. And again, with lots of other things, I need to create an API key at Pinecone. And so I will do that, and then we'll put these documents in there for that. And then we'll store the metadata in there. So Pinecone will have not only the embeddings, but also what documents they come from. So, and then once we have that, we can then retrieve, given a query or a prompt through the LLM, we can feed that to Pinecone and say, which that. Now what, in order to do that, we take our query, we have to convert it into an encoding like we did with our original documents. We feed it then to Pinecone and say, what other things are close numerically to this? And it does kind of what we call a semantic analysis or lexical analysis, where it'll find similar words or related words in the query and in all the documents and return documents that match there. So and we can specify, oh, we want the top 10 documents or top 5 documents, top 100 documents. And not documents, I'm sorry, I should say chunks. So we can say, I want the top, 20 chunks of data from our Pinecone database that are related to the query. And then we're going to query the actual system. We're going to take our question, our original prompt. We're going to embed the chunks from the 3 documents there, and then we'll generate an answer, and it'll provide references. And again, because of the metadata stored in Pinecone and in these chunks, so every chunk will come back with this is like this page in this document. And so the LLM can then give us the answer and also tell us what document those are from. Again, that might sound like a lot, but again, it is just this much code generally. It is just, here are our documents. We're reading those in and creating and setting up. Here, we're splitting our documents up into chunks, 1,000 character chunks with overlap of 100. So we have our document chunks. Here, we're generating the embeddings for those. Now we're setting up Pinecone with our APIs there, and then we're creating a new index. And now we're putting all of our documents, all of our chunks into this index. So we now have what is called a vector store with our embeddings and our document chunks. And now here's our chain. We're going to create an LLM. We're going to create a retriever from the vector store, our data here, and then we're going to retrieve it. We're going to say, use this LLM, use this retriever, and then go out there and get the data. And then it'll give a chain, and then we can pass our query to that chain, and it'll give us our answer. So this is kind of how we'll set up this. And again, this has changed quite a bit from last year in the last 12 months. So again, this is stuff I'm updating because last year's example was a little more, again, not so straightforward because RAG was available, but it wasn't built so well into LangChain and models like that. It wasn't so easy. Now you might ask, why am I teaching how to do this in code when you could just do this in like Notebook LM? And again, my reason is that we have different people in this class. Some of you are going to want a no-code version of this sort of stuff that you want, but some of you are going to be working at companies and developing RAG systems, and you'll want to develop your own, set up your own versions of this and program it. So that's what we'll do. I will give you, again, this basically programmed, and we'll work with it. So I'm not going to have you write this. This example here was actually all AI generated for this stuff. So we'll look at that. So that's what we'll look at on Thursday, is this sort of system. Okay. All right. I'm just going to note what let's see, we do have time today, right? I think we have time. Good. I'm just going to talk a little bit about the project for the next 2 weeks. Oh, yes. So I've opened up the final project. And let's just talk a little bit about that. A final project is a research project where you want to pick a project you want to research, uh, and it has to have an experiment in it. So it has to be kind of part of the scientific process here. You've got to do a literature review, review some current research. You're going to do a simulation with some sort of data, some sort of results. So you have to actually do something. You have to have a hypothesis. You have to, state your position or hypothesis, and then you're going to test out that hypothesis to see it's accurate. We did this once before, kind of when we were doing image processing with CNNs. Remember, you had to do a project where you took a CNN and you made a hypothesis about how to improve it, and then you tried that out here. And similar, you could do something like that here, but this allows you to do kind of a deep dive into some area we've covered in the class so far that you want to explore some more. And again, we'll talk more about the paper later, but that's the paper. And then now back to this project is, again, another kind of trial run at that stuff. So it is an LLM experiment here. So you want to select something we've been doing with LLMs. So prompt engineering, working with LangChain, working with agents, working with retrieval augmented generation, any of the stuff we've been working on the last few months, anything related to LLMs. I'd be even interested in some of the newer stuff, like some of the reasoning models of LLMs, stuff like that. I want you to make a hypothesis. So maybe you're, including a longer backstory in agents and crew AI will generate better responses, or, automating or, one-shot prompts generate better, more accurate responses than zero-shot prompts there, or something like that. So you want to make a hypothesis. We want to test this out. Now, to test out, we want to identify independent variables and dependent variables. So independent variables is what we're going to change. We're going to try, we're going to test out zero-shot versus one-shot prompts. And that's independent. That's the only thing we're going to try to change. And so dependent variables is what we're going to then measure. How are we going to test the results? The prompt accuracy, the prompt consistency. How do we measure that result there? And so with prompts, it's sometimes, or responsive LLM, it's sometimes hard to tell, is one better than the other? So how are you going to measure that? And then, so once we define those, we want to keep everything else generally the same here, or see the results. So again, we're going to try to clarify the hypothesis here. And again, it's sometimes nice if we can be measuring quantitative results. For example, maybe the number of words in the backstory and the amount of detail, the length, the amount of words in, so something we can measure, like the number of words in the backstory, is a little easier to measure. Sorry, I didn't mean to do that. It's a little easier to handle than things like how detailed, what does detailed mean? How do we measure that? Now, we can't measure everything. So some of this stuff is qualitative rather than quantitative. And so how do we handle qualitative data? For example, if we look at this, we were looking at responses from GPTs. And if we look at one response versus another response here, how do I say that this response from Notebook LM was better than this response from my custom chat GPT? So how do I measure that? What do I see? So you might have to ask, say, maybe we create a rubric to score it, or we somehow code it. or there are different ways of doing it. So a rubric would just be like, how many, in the responses, how many false facts were there? How many correct facts there were? Or something where we try to apply some numbers. So for every false fact, they'd lose a point. Every correct fact, they'd gain a point or something like that. So we had to come up with some sort of scoring or grading system to grade or score like the LLM. So, like, what does it mean to have one prompt higher quality than the other, or one prompt more accurate than the other? What does accurate mean here? And then go on test. Now, this might seem really complicated, but it's really not that bad. I mean, like an example you could do is do some of these reasoning models work better than the old traditional models here? So does like Chat GPT 01 with advanced reasoning work better than Chat GPT 4 on this type of question? And so maybe we'll phrase a certain type of question. I think we don't travel enough, it sounds like, in this stuff. So maybe if we're planning a vacation here to a certain and maybe we do 3 different trips, and we'll have it plan out 3 different trips there. And maybe we do a driving trip, a flying trip, and a bus trip. I don't know. Here, so we create 3 different prompts there, and we ask Chat GPT 4 each of those prompts, and we ask one of the newer models those 4 prompts, and then we score the results. And again, you have to come up with some little mechanism to score the results there. So you come up with some way of applying a score to the results. You score each result, and then you see does one of these models perform better than another model here. So again, you can do something like that again, and there's lots of ones. If you want to do some programming, you can do anything related to modifying one of our previous ones, like when we did the crew AI. If you had that, what if you modified something in that crew AI to modify how the crew was set up? Does that improve the performance or not? Okay. So again, that's the project here, and you just have to do it by the end of next week here. So I just want to get you thinking of that. Okay, I think we're going to wrap up now. So hopefully you finished. Did you finish? You finished part 1 of the RAGs of the learning activity, hopefully today. I'm good. Let me know if you have any questions.